Welcome back, dear students. In today's Zoom revision class, we revised question number 5 to 10, chapter number 12. The topic is the physical properties of alkane. First of all, there are two types of properties, the chemical and the physical properties. So the physical properties depend upon the molecular mass, and molecular mass is the number of proton and neutron in the nucleus, while the chemical properties are related with the involvement of electrons. So physical state, the first four alkane members are methane, ethane, propane, butane, and these are gaseous in state. As their molecular weights are smaller, so their physical state is also very much lower, that is gaseous state. Next 13 members are colorless liquids, while the higher members of the series are solids. They are, as you know, organic compounds. The hydrocarbons are non-polar in nature, so they will be insoluble in water because water is a polar substance, and they will get dissolved easily in the non-polar solvents like the benzene, ether, acetone, etc. Their melting and boiling point increases with the increase in molecular mass. So the methane, which is the first member of alkane series, is having the boiling point of minus 162 degrees C, as it is in the gaseous state. So you can see that the boiling point is very much lower, while the second member of this group, that is ethane, is having a boiling point of minus 89 degrees centigrade, which is higher than methane. So as we are going downward in the homologous series of alkane, the molecular mass increases, and due to the increase in molecular mass, the boiling point also increases. The density, again, it depends upon the molecular masses, so density will increase regularly in the series with the increase in molecular mass. Alkanes are less inflammable, less volatile, but they are more viscous in series with the increase in molecular mass. Question number 9 is important reaction of alkanes. Chemical properties are dependent upon the involvement of electrons. As alkanes are saturated hydrocarbons, so they are having all single covalent bond. As its valency is fully satisfied, so it will not undergo the addition reaction. However, they can be make reactive by applying certain condition, like we can apply the heat and we can also provide the light. So they are will show the substitution reaction, not the addition reaction. Its first reaction is all of these reactions are substitution reaction. Substitution reaction is the replacement reaction, a reaction in which an atom or a functional group is replaced by a different functional group in organic compound. That is called the substitution reaction. Halogenation, the substitution of hydrogen by halogen in alkane, is called the halogenation. Alkane react with the halogen in the diffuse sunlight and produced alkyl halide and hydrogen halide. Look at the structure. We are having methane, and we are using chlorine molecule, and the hydrogen will be replaced. In the first step, one hydrogen will be replaced and methyl chloride or chloromethane will be formed. In excess of chlorine, the reaction will not stop, and we will get a series of reaction and compounds. The second reaction, the same methyl chloride will react further with the chlorine molecule, and another molecule, another atom of hydrogen will be replaced by chlorine. Same is the case when all of the hydrogen atoms will be replaced. In the third step, you can see that third one hydrogen is replaced by the Cl, while in the fourth one, at the last step, all of the hydrogens are replaced by the chlorine, and that compound is called the carbon tetrachloride or tetrachloromethane. Another important reaction which the hydrocarbons show is the combustion reaction. Combustion reaction is referred with the burning of carbon. When alkane react completely in the burn completely in the presence of excess of air, focus on the excess of air, so it will produce a lot of heat, carbon dioxide, and water will be produced. CH4 reacted with 2O2 means to say that there is an excess of oxygen. We will get carbon dioxide, water, and heat. As it is evolving the heat, so it is the exothermic reaction. But if we are having less availability of oxygen, so instead of carbon dioxide, it will produce a lethal gas, a poisonous gas, which is called the carbon monoxide, and it will be having some unburned carbon atom. As you can see, for two methane molecule, we are having 3 oxygen atoms. Clear? So it is insufficient for its complete oxidation. It is exothermic reaction because it produces heat. Next question we are having is the define alkenes. So alkenes are unsaturated hydrocarbon. They have a double covalent bond. Their general name is olefin because these are oil formers, and their general formula is CnH2n. The general formula of alkane is CnH2n plus 2, and over here it is having 2 hydrogen less than the alkanes. Important alkene जो generally यूज़ किया जाता है वो प्लांट हार्मोन है जिसको फ्रूट राइपनिंग के लिए यूज़ किया जाता है, जैसे कि ईथीन. ठीक है. These are the structures and their formula, condensed formula and molecular formula of the sum of the alkenes, and these are the structural and cross and dot structure dot and cross formula of alkenes. Naming for rules for naming are as like the alkanes, but the difference is there that it is having the double covalent bond, so the A and E will be replaced by E and A. We will show the position of double covalent bond. The first structure you can see is called ethane. The second one is propane. The third one is having 4 carbon atoms, and the double bond is situated at carbon number 1, so it is called 1-butane. In the last one structure, the bond is located at 2, so it is called the 2-butane. Look at the structure. So it is having the 4 carbon atoms, and the rest of the groups are acting as a substituent. So we will write the position of the substituent, that is 2,3 hyphen dimethyl 2-butane. Same is the case with the other one structure, so we have to give the number accordingly. Alkenes are prepared by elimination reaction. Elimination reaction is when atoms are removed from a molecule or 2 adjacent carbon atoms of the saturated organic compound. It will result in the formation of double or triple covalent. For alkene, we will use dehydration process and dehydrohalogenation process. First of all, dehydration, and the word D in chemistry is used for a removal. So dehydration, water is to be removed from alcohol. Condition for this is the sulfuric acid, and temperature provided is 180 degrees C. From the given structure, you can see that from one carbon atom we will remove the OH group, and the other one carbon atom we will remove the hydrogen. These two will combine to form the water molecule, and the structure, the carbon will form double bond, so alkene will be formed. Second process is dehydrohalogenation process. So dehydrohalogenation means removal of hydrogen and halide from alkyl halide, and the reagent used over here is potassium hydroxide. Clear? So when alkyl halide such as ethyl chloride is heated with an alcoholic solution of potassium hydroxide, what will happen? The removal of hydrogen takes place from one carbon atom and chlorine from the adjacent carbon atom. So it will form a double covalent bond, and HCl will be released. Next question we discuss today is the physical properties of alkene. These are similar as the alkanes. The first 3 members of the series, because methane is not existing, butane, propene and ethene, they are gases, others are liquid, and higher are solids. They are insoluble in water because they are non-polar in nature, so and water is polar in nature. Their melting and boiling point increases with the increase in molecular masses, and they are flammable hydrocarbons, and on complete combustion they produce carbon dioxide, water, and with the release of large amount of energy. It means that these are the exothermic reactions.